This lecture is based on the textbook Combinatorics and Graph Theory. We're looking at section 1.3.2, Properties of Trees. So let's try an experiment. I want to draw a tree of order 16. So here I have 16 vertices and I can just draw a graph. I just have to make sure that the graph is connected and that there is no cycle. And yep, so now let's count the number of edges. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. We have 15, which is 16 minus 1. This is true in general. So if T is a tree of order n, T has n minus 1 edges. Let's discuss the proof. We do induction on the order of T. When the tree has one vertex, the only tree is the one with 0 edges. So that's the base case. Now assume that the statement is true for all trees of order less than k, and let T be a tree of order k, or prove that the statement is also true for T. So now choose some edge of T and call it E. Since T is a tree, it must be that T minus E is disconnected, and there are two connected components. There are trees themselves, like in this figure. So let's call the two components T1 and T2. Let K1 be the order of T1 and let K2 be the order of T2. And so K1 and K2 are less than K, and also K1 plus K2 is equal to K. Now since K1 is less than K, the statement is true for T1, and so by the induction hypothesis, the statement T1 has K1 minus 1 edges, and again the statement is true for T2 because K2 is smaller than K, so T2 has K2 minus 1 edges. Now the edges of T is the disjoint union of the edges of T1, the edges of T2, and this edge E. And so the number of edges of T is the number of edges of T1, which we have computed to be K1 minus 1, and then the number of edges of T2, which is the same as K2 minus 1 plus 1 for E. And so we have the result that this is equal to K1 plus K2 minus 1, but K1 plus K2 is equal to K. And so we have shown that the number of edges of T is K minus 1. So here are some theorems about trees, which shows that we could have defined tree differently. So we could have said that a graph of order n is a tree if it is connected and contains n minus 1 edges. We could also have defined a graph of order n to be a tree if the graph is acyclic and contains n minus 1 edges.